Imagine trying to translate like 5 different languages simultaneously, flawlessly, while running a marathon backwards.
Yeah, that sounds like a total nightmare.
Right, but that kind of invisible heavy lifting is exactly what is happening behind the scenes of every pristine live stream you watch. We usually just assume it's digital magic.
Well, it feels like magic sometimes, but it's really just heavy-duty hardware doing the work.
Exactly. So today, our mission for this deep dive is cutting through the dense audio and visual jargon of one specific piece of hardware. We're looking at the Kiloview KVW-RD-260 decoding card.
Ah, the RD-260, a real workhorse for modern remote education and broadcasting.
Yeah, we are going to figure out how this little device actually powers all that. Okay, let's unpack this using our source material from HDTVSupply.
It's a great starting point, honestly, because before we get buried in, technical spec sheets, we really need to look at what this physical card actually accomplishes in the real world.
Right, because before reading this, I assumed video just flowed through cables naturally. But looking at the sheer chaos of internet data, is it fair to think of this card as a high-tech universal translator?
A universal translator, I like that.
Like taking the wild data flying across the web and forcing it into a smooth, watchable video signal.
That captures the core function perfectly, yeah. At a physical level, the card has IP video streams pouring in through 2 gigabit Ethernet ports, because the internet doesn't transmit video as a continuous movie, right?
Oh, right, it chops it into billions of messy data packets.
Exactly. So this card catches those packets, reassembles them, and outputs them into rock-solid broadcast formats via HDMI and 3G SDI.
And that 3G SDI connection is crucial here, right?
Totally crucial. It's the industry standard cable that allows uncompressed video to travel hundreds of feet around a massive studio without losing a single pixel of quality.
Wow. And it has to be translating the audio at the exact same time.
It is. What's fascinating here is how it seamlessly handles embedded AAC audio right alongside the video.
AAC, so that's the compression standard, making sound files small enough to stream.
Right, so they don't sound like they were recorded underwater. But if a studio setup requires the audio to be routed to a completely separate mixing board well, the card allows the user to extract it directly into a standard 3.5 millimeter analog output.
Okay, so it's translating raw data to video and audio. But the internet is inherently messy. How does this tiny card handle it if a broadcaster suddenly sends multiple feeds using completely different software?
That is where the heavy lifting really comes in.
Because, looking at the source, there is this massive list of supported protocols. We're talking NDI, SRT, RTMP, HLSTS. I mean, it reads like alphabet soup.
It really does.
So does a typical broadcast setup actually need all of that? Or is this just unnecessary future-proofing?
No, it's actually vital for survival in broadcasting today. Internet video arrives in different languages, so to speak.
Okay, give me an example.
Well, for instance, SRT, or Secure Reliable Transport, is specifically built to survive terrible, choppy internet connections. It recovers lost data packets in real time without dropping frames.
Oh, wow. And what about NDI?
NDI, on the other hand, is built for lightning-fast, high-quality video sharing over a local network. And this card is fluent in all of them.
That is wild.
Yeah, combined with its H.265 and H.264 decoding capabilities, it really doesn't matter what format the incoming stream is in, it can read it.
Let's put the raw power of that into perspective for a second. Because the specs say it can decode up to 4 video channels simultaneously at 1080p 30.
Yep, or 2 channels at the faster 1080p 60 frame rate.
That means this single card is actively catching, unpacking, and perfectly rebuilding 4 entirely separate high-definition movies 30 times every single second.
Exactly, without breaking a sweat.
Here's where it gets really interesting. 10 years ago, decoding that massive amount of simultaneous data required a server rack that cost thousands of dollars.
Oh, easily.
Now, you get all of that robust processing power for an MSRP of just $499. Plus, the source mentions a 10% discount code. That completely changes the scale of who can afford to build out a professional broadcast studio.
It democratizes the technology, absolutely. But, there is a structural catch.
Oh, really? What kind of catch?
Because this is explicitly a module card, you can't just plug it into a wall socket on its own. It physically requires a larger infrastructure.
Ah, I see. So it needs a home.
Right. Specifically, the RD-260 is designed exclusively to slot into Kiloview's Cradle Series 1 or 3 RU frames.
RU standing for rack unit.
Exactly, the standard sizing for broadcast server racks.
So it's not a standalone box. It's basically a piece of a much larger, expandable puzzle.
Spot on. And if
Yeah.
we connect this to the bigger picture, we have to look at the retailer HDTVSupply.
Right, because they aren't just selling one-off pieces of plastic here.
Exactly. They are a 25-year-old institution with over 10,000 positive reviews. They have this massive web of strategic partnerships across the industry.
Which makes sense. When a university or a news station builds out a studio, they rely on that kind of institutional backing to supply an entire rack system, right?
Absolutely. They need that reliability.
So what does this all mean? It means this hardware acts as a scalable building block for massive professional systems. You buy the frame, and you populate it with cards like the RD-260.
Yeah, you just slide them in side by side to fit the exact scale of your project.
That is incredible.
It is. And this raises an important question regarding just how much invisible hardware is required to keep our globally connected world running flawlessly.
Yeah, we just consume the final image, completely unaware of the sheer computing power required to drag that image across the globe.
It's staggering when you really think about it.
It totally changes how you view a simple live feed. So, the next time you are watching a pristine live stream, take a moment to wonder, what kind of decoding hardware is quietly grinding away in a rack mount somewhere to make that digital magic happen?